All right, algebra students, here we go. We're going to do our transformation notes today. We've got our three types of shifts, vertical, horizontal, and stretch. We're going to be using f of x is equal to x, and it's our parent function. Slope is 1, y-intercept is 0. Critical to remember, this is just function notation. You can also see this function looks just like this. Y and x are equal, just like f of x looks a little bit better. And if you recall, I'm going to make a table of values. Your slope is 1, that's the number paired with x, and your y-intercept is 0. So to put it in mx plus b form, it looks just like this. And if I want to pick some x values, my f of x values would be exactly the same. So if I pick 2, y would be 2. If I pick 4 for x, the function value would be 4. And if I pick negative 3 for x, the function value would be negative 3. You're going to get some points that look just like this. I'm going to use my handy little straight edge here. And it looks just like this. This is our most basic graph, slope of 1. So we go up 1 over 1. And we're right here at x equals 0, y equals 0 for our intercept. Transformations are when you take a function and shift it. Some handy rules. They're going to look like this. This looks a little intimidating. It's not so bad. We're going to talk about it as we go, take them one at a time. Anything that you do outside the parentheses is going to be shifting up or down when we're adding and subtracting. This is for adding and subtracting. Anything inside the parentheses is going to shift left or right. If it's inside the parentheses, it's going to be opposite. So example, if we're taking something away, we're going to be moving it to the right. If we're adding something inside the parentheses, we're going to be moving it to the left. Let's get some examples here. On this first one, we're outside the parentheses. Our new function, and again, what I'm going to do is I'm going to take and get myself a nice, this is f of x, all right? F of x is going to be purple for the entirety of these notes. This is the function we're starting from. G of x is going to be our change. We'll make it hot pink. Really easy to see. We're going to take our function f of x and we're going to shift it down 4 units. So I'm going to take my y-intercept, I'm going to shift it down 4 units. I know I've still got a slope of 1 over 1, but you can also take and pick any of these points and shift it down 4 units. This is my new function. It's called g of x, and it's 4 units lower than my function f of x. My other one over here, again, I'm going to start off with my f of x. Looks just like that. F of x again, purple. G of x, we're going to shift it to the right 3 units. So again, to the right. And you'll notice shifting it down 3, shifting it to the right 3, you're going to end up getting that same line. Don't worry too much about that action, and just worry about how that shift is going to affect your line. Now, this scale's a little bit off, but that's okay. Anyway, it should be parallel. The fact that our x's are a little bit scrunched and our y's are not is going to make them not parallel visually, but they will be actually. So again, if it's outside, we're talking about shifting up or down. And it's going to be exactly how you think. So a positive shift outside would go up. In this case, a negative shift on the outside is going to go down. On the inside, we're looking at left and right. A negative on the inside is going to push us to the right that many units, and a positive on the inside is going to push us left that many units. We're going to get that exact example right here. So again, starting off, we have a new f of x function, negative 2x plus 4. So here's a plus 4. Here's a couple of negative 2 points. Looks just like that. Got my line going. This is my line. If I want to shift this line up, there are 2 ways to think about it. I'm shifting it up 2 units, so it would be the exact same function. Instead of starting at 4, I'm going to shift up 2 units. I would start at 6. And you're going to have that same slope. If you'll look at every single point, it's simply been moved 2 units vertically. Simply been moved 2 units vertically. Looks just like that. Over here, we're going to move it on the inside 3, and this one's a little bit harder to adjust. It's negative 2 of x plus 3, plus 4. That's my new x value. I should have written that in purple, or hot pink rather. And let's talk about what that looks like in the graph. We'll make the shift first. So my first graph, we had a positive 4, we had a slope of negative 2, still this purple graph right here. And we're going to change it. So it's the same graph, we're going to make this shift of 3 units, and this time it's going to be 3 units to the left. If you think about it, x plus 3 is going to be 3 units advanced of what it should be. So example, positive 1 will be the same as taking negative 2 and adding 3 to it. Alright, so you're using a 3 advancement on that x. That's why it's moving to the left, because negative 2, we're going to add 3 to that, and it's going to act the same way as it would if that x value was a positive 1. So I'm going to get those points. To go short story on you, if you have a plus 3 on the inside, you're going to shift all your points over to the left 3 units. The next transformation we're going to have is called a reflection. We're going to get our reflection on, and it's basically flipping the graph either over the x-axis or the y-axis. And examples are better than talking. Examples are better than talking. So our very first one, I'm going to have this graph. Again, I'm going to do it in purple for my original graph, and then I'll show you the translation. We've got this negative 2 where we're going to start from, and we have a slope of positive 1 over 2. So this graph will look just like this. Positive 1 over 2. There's my graph. And what I want to do is I'm going to flip it. Alright, it's just that negative sign. We're going to reflect it across the x-axis. So on this one, everything is going to go negative. You'll notice this negative involves the entirety of the function. So if it was positive, it's now negative. So instead of positive 6 being my y, negative 6 is going to be my y. Instead of positive 8 being my y, or positive, I apologize, instead of positive 1, negative 1, instead of positive 2, negative 2. Everything is going to have the opposite y value because we're taking the function and we're multiplying our final answer by negative 1. The opposite is true here. We're taking our x value and we're multiplying it by negative 1, and I'll show you what that does. It's going to flip it over the y-axis, yes, but let's get some. So here's my original starting equation right here. Now, the x value is what's shifted. So when I put in a negative 2, it's going to act the same as a positive 2 would. I'm going to get that function value of negative 1. When I put in a negative 4, it's going to act the same as a positive 4. So it's going to give me a function value of 0. The same thing is true as I go back in here. If I put an x value in of positive 2, it's going to give me the same function value as a negative 2 would have. So on this one, you'll notice it flips over that y-axis. The y-axis is the mirror. So a very similar line to this one, it's just going to flip over the y-axis instead of the x-axis. We can cut the video here.